Alright, so we are going to talk about graphing quadratic functions today. And we're going to be doing this not by making a table. We're going to have some different steps we can do. So first, I want to talk about the standard form of a quadratic function. So if we have a quadratic that's in the form y equals ax squared plus bx plus c, there are some steps we're going to do in order to graph this. The first step is to find the axis of symmetry. Now, in our last set of videos, we talked about how the axis of symmetry is a line where it's set as x equals the opposite of b over 2 times a. Once we've found that, what we can do is find the vertex. Which the vertex is going to be a point where we take our axis of symmetry, negative b over 2a, and I'm going to put a notation here that might look a little weird, but all it means is we're going to take x and we're going to put it back into the equation. So we're going to go f of negative b over 2a. So in the equation, y equals ax squared plus bx plus c, we're going to take negative b over 2a and plug it in. Our third step is to find the y-intercept. Now, that's going to actually be a fairly easy thing to do. It's going to be a point where the x value is 0 and the y value is just the value of c. Once we've done that, in step 4, we're going to pick 2 more points. I'm actually going to type this one. We're going to find 2 more points on the same side of the axis of symmetry as the point containing the y-intercept. Once we've done that, we're going to go on to step 5. Step 5 is to graph the axis of symmetry, the vertex, the point containing the y-intercept, and 2 other points. And then there is one last step, so I'm going to have to put that on our next page. Step 6 is to reflect the points across the axis of symmetry and then connect the points with a smooth curve. So let's look at an example. We're only going to do one example in this video. So let me pull up some graph paper. We are going to graph y equals x squared minus 4x minus 5. So our first step is to find the axis of symmetry. Now remember, all quadratics are in the same form. We can write them in the form ax squared plus bx plus c. So the axis of symmetry, we take negative b over 2a. So we're going to take negative 4. So we've got negative 4 over 2 times 1. So our axis of symmetry is x equals, well, when we take the opposite of a negative, we're going to get a positive. 2 times 1 is 2, and 4 divided by 2 is going to be 2. So our axis of symmetry is going to be at x equals 2. Our second step is to find the vertex. So we're going to take 2 from our axis of symmetry for the x value, and then we're going to plug 2 in to our equation. So we're going to go 2 squared minus 4 times 2 minus 5. Now I put parentheses around 2 because if that 2 was negative, the result is going to be different. So 2 times 2, we know that's 4, minus 4 times 2 is 8, minus 5. Well, 4 minus 8, that is negative 4. And if we subtract 5 from that, we're going to get negative 9. So our vertex is going to be at the point 2, negative 9. Step 3. We are going to find the y-intercept. All that's going to be is the point where x is 0 and y is c. Now the y term is a c term, is negative 5. So our y-intercept is 0, negative 5. If that was a plus 5, then we'd have a positive 5. Now with step 4, we're going to pick 2 points on the same side of the axis of symmetry as the point with our y-intercept. Since our axis of symmetry is at 2, we're going to, you can pick anything that is on the same side as 2 as 0. For example, I'm going to pick 1 and negative 1, and I'm going to plug those in for x and figure out what y equals. So we'll end up with 2 points, one where we've got a point x1 and another point where we've got x negative 1. You might use different numbers, and that's okay. So we're going to go 1 squared minus 4 times 1 minus 5. Well, 1 squared we know is 1. 4 times 1 is 4. So 1 minus 4 minus 5. Well, 1 minus 4 is negative 3. Negative 3 minus 5 is negative 8. So we've got 1 point at 1, negative 8. And then we plug negative 1 in. So we're going to have negative 1 squared minus 4 times negative 1 minus 5. Well, negative 1 squared is 1. Negative 4 times negative 1 gives us a plus 4 minus 5. Well, 1 plus 4 is 5, and 5 minus 5 is 0. So our other point is going to be at negative 1, 0. So we need to keep these in mind when we now graph. So I need space. I'm going to clear the page, and I'm going to write down just the important parts of what we have written down here. So now that I've got my points, what I'm going to do is create my graph. Now I see most of my y values are negative, so I'm going to keep that in mind, and I'm not going to go too positive with my y. axis. So we're going to start by putting an imaginary line. We can make it dotted so we can visually see it at our axis of symmetry. So at x equals 2, we're going to put a horizontal line for our axis of symmetry. In a way, what we're going to do with that is treat it like a mirror. So once we graph these points, we can make a mirror image of it on the other side of that axis of symmetry. Our vertex, we said, is at point 2, negative 9. So we're going to start at the origin, go right 2, and down 9. We're going to put a point right there. We also know our y-intercept is at 0, 5, so from the origin we're going to, in fact, 0, negative 5, we're going to go from the origin down 5. We're going to put another dot there. And then we've got 2 more points. We're going to go 1, negative 8, and put a dot there. And then negative 1, 0, and put a dot there. Now, for graphing, all we're going to do is treat that axis of symmetry like a mirror. So we're going to take the point that's at 1, negative 8, and we're going to put it at 3, negative 8. At 0, negative 5, we're going to put it at 4, negative 5. And at negative 1, 0, we're going to go to 5, 0. So we've got our reflected points. Now all we're going to do is connect these dots with a smooth curve, as smooth as we can make it. Let me redo that part. Alright, so we now have our quadratic function graphed. Now if we just remind ourselves, our equation was y equals x squared minus 4x minus 5. What we learned in our last set of videos with characteristics of quadratics, if this a term, this first term, is positive, our parabola should open up, which means we have something that's in the shape of a U, which is what we have here. Now I said we were just going to do one example for this video, and I'm going to hold to that. Since we have finished graphing our equation, we're done. Our answer is our graph.